Hello and good day, Algebra. We are covering linear functions today. And we've talked about functions earlier in the unit. We had function notation. We know what a function is. It can be represented by a table or a graph. It means that every x value has exactly one corresponding y. But today we're adding a word in front of it to make it like a special type of function. Okay? Does anybody know or have a guess what a linear function is going to be? And really your key word here is linear. What does linear mean, John?
Right there on the board?
Yes, it does say linear right there on the board.
That's what it's going to be.
Oh, some of these are, not all of them though, okay? But a linear function in general, yeah. It's a line, okay? A linear function is a function that is a line on a graph. Okay? A linear function is a function that is a line on the graph. A linear function is a function that is a line on a graph. So it's pretty easy when you're given a coordinate plane to determine whether or not it's a function. That's why I only give you two of them here. Okay, which one of these is a function? Which one of these is a linear function and which one isn't? Or are they both? Or are neither of them? Which one fits the definition of a line on a graph? Maggie? The first one, right? Yeah, the one on the left, okay? This would be a linear function. It's a line on the graph. And this one would not be, okay? It's not a single straight line. It's made up of, two segments here, or rays, okay? But this would be a linear function. This is not. Is this a function? Yes. The vertical line test would tell us that, anywhere we put a vertical line, it only hits the graph in one spot. So it is a function. In fact, we have this exact same graph on our function page in CO19, but it's not a linear function. A linear function is specifically a line on the coordinate plane. Okay? And what makes linear functions special, other than being a line, is that every linear function, hold on. Okay, we'll do that. Every linear function has slope. We talked about slope a lot last year in pre-algebra. How to find slope with a formula, how to graph an equation using slope. What is slope? What are some of the, we define it like 3 or 4 different ways. What is slope? So slope-intercept form is mx plus b, right? Where that m variable is the slope of the line. And when you graph an equation in slope-intercept form, how would you use that m variable? How did you use the slope to help you graph it? Or when you were given a line and wrote the equation of it, how did you use the slope of the line from the coordinate plane to put it into your equation? How does slope relate to lines? Leah? Rise over run, right? That's a slopey thing to say, okay? What does rise over run mean? Yeah. Sure, it's how far you go up or down, right? And then how far you go over. The slope of, the slope of our linear function here, from point to point is going to be up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, right? That's how the line moves across the coordinate plane. In the second one, that is a function but not a linear function, notice how our slope changes. We go down 1 over 1, down 1 over 1, but then we go up 1 over 1, up 1 over 1, right? And these two slopes, down 1 over 1 and up 1 over 1, are different. That's why it's not a linear function. Okay, it doesn't have the same slope throughout. So rise over run, how far you go up versus how far you go over. Another way to say that is this right here, the change in y over the change in x. Because when you count up or down, that vertical axis on the coordinate plane is the y-axis. You're calculating the change in the y values of your pairs. And when you go across the x-axis, you're looking at the change in x. So slope is a rate describing how a line moves across the coordinate plane. Okay? A rate describing how a line moves across the coordinate plane. I'll make moves more legible. There we go. A rate describing how a line moves across the coordinate plane. And for our purposes of finding linear functions, we're going to focus on this change in y over change in x. I'm going to scroll down a little bit here, so give me a thumbs up when you got the notes and ready to move on. Good? A rate describing how a line moves across the coordinate plane. Okay? Okay. So when we look at change in y over change in x, I've got a bunch of function tables here, and I've got these little rectangular ears on the side of them. What we're looking for here, that change in y over change in x, what's the change in y to go from -3 to -1? What's the change in y to go from -3 to -1? Lauren? +2. -3 plus 2 is -1. Okay? Then we look at the next set of y's. What's the change in y from -1 to +1? Ifan, was that a hand up? No? What's the change in y from -1 to +1? How far apart are -1 and +1 on the number line? Which direction do you go? Lila? +2 again. Okay? And then what's the change in y from 1 to 3? Aiden? +2 again. Okay? So far, this is looking good to be a linear function because our change in y is consistent. +2, +2, +2. But the other piece of this is the change in x. So then we look at our x values here. What's the change in x from 1 to 2? Everybody. +1. Thank you, everybody. What's the change in x from 2 to 3? +1. And then change in x from 3 to 4? +1. Right? So if we look at each set of ordered pairs individually, right, this is a slope of 2 over 1, change in y, 2, over change in x, 1. This is also a slope of 2 over 1, and this is also a slope of 2 over 1. Because these three are the same, do we have a linear function? Yes, we do. Okay? And the reason why it is a linear function is because it has slope. The slope of this relation is up 2 over 1. Okay? Questions on what we just did there? Your first step is to find that change in y. Your second step is to find the change in x. And then you want to compare them and see if they're all the same. Okay? If they are, linear function. If they're not a linear function. So, second one. We'll start again. What's the change in y here from 0 to 2? It happens to again be +2. From 2 to 4, +2. From 4 to 6, +2. All right, step 1, find the change in y. Did that. Step 2, find the change in x. What's the change from 12 to 15? From +12 to +15. John? +3. How about 15 to 18? +3. 18 to 21? +3. Okay? So looking at each of these individually, right, we got change in y over change in x. That's a slope of 2/3. Here's another 2 over 3. And here's another 2 over 3. Okay? Do we have a linear function? Yes, we do. Okay. Questions so far? Pretty straightforward. Using this table to identify if there's slope by looking for that change in y over change in x. The one thing you got to be careful of is an example like in the third one here. If you're kind of working ahead and you're saying, okay, 48 to 56, that's plus 8. 56 to 72, that's plus 16. Uh-oh. 72 to 80, that's plus 8. At first glance, you might be thinking, that's not the same, not a linear function. But you have to also do the change in x. Because when we do that, watch what happens here. 5 to 10 is plus 5. 10 to 20 is plus 10. 20 to 25 is plus 5. Tell me why this is actually a linear function. Even though it might not look like it, because in these first two examples, everything was the same, right? Plus 2, plus 2, plus 2, plus 1, plus 1, plus 1. Second one, plus 2, plus 2, plus 2, plus 3, plus 3, plus 3. That doesn't happen here, but it is indeed a linear function. Leah, why? There's a pattern, but more so than that. Connor? No, say what you're going to say. I think you might be on the right track. So yeah, if we look at kind of what we did, these things individually, we get 8/5. I'm going to write it down below here. Our first one, change in y over change in x, 8 over 5. Our second one, 16 over 10. And our third one, 8 over 5 again. What Connor's saying is that actually all three of these fractions are equal. Because that fraction 16 tenths, remember we defined slope as a rate? The rate of 16 over 10 can be reduced to be 8 over 5, right? These three values are all the same, even though the numbers are a little bit different. But we know that from fractions, right? You can have equivalent fractions, equivalent rates. Because these rates are all equivalent, this also is a linear function. Okay? Those of you that have kind of worked ahead a little bit, is there one on here that is clearly, absolutely not a linear function that we can go over? Morgan. The one below the first one. First one, second row. Okay? So let's take a look at this. Our first step, find that change in y. Plus 25. 50 to 50 is plus 0. 50 to 25 is minus 25. This is not looking good for linear function status here. Going over to the x's, 100 to 200 is plus 100. 200 to 300 is plus 100. 300 to 400 plus 100. Okay? So there's consistency there within the x variables, but if we take these individually, like we did with the third one, we've got a change in y of 25 over a change in x of 100. Then we've got 0 over 100. And then we have negative 25 over 100. Those three values are not the same. Right? 25 hundredths is 1/4, 0 hundredths is 0, and negative 25 hundredths is negative 1/4. So this would not be a linear function. Okay? Questions on any of this? How would you get a negative slope? Like here, the slope was positive 2 over positive 1. Here was positive 2 over positive 3. Here the slope is positive 8 over positive 5. This one doesn't have a slope, so it's not a linear function. How would you get a negative slope? Yeah. Right. Both numbers going down or just one of them? If both the change in y and change in x were decreasing, would that be a negative slope? Or only one of them decreasing? Well, let's just say that we had a function table, so that don't put this in this spot because it's not part of your homework. But let's just say we had something like 15 and 7 and 1 and 4 and 1 and -2. Okay? What's the change in y from 4 to 1? -3. What's the change in y from 1 to -2? -3. What's the change? Oh, I did this wrong. It should be a -1. That's embarrassing. What's the change in x from 15 to 7? -8. And what's the change in x from 7 to -1? -8. So in looking at this, the slope of this, right, where we kind of looked at these individually, the slope would be -3, that's our change in y, over -8. Is that going to result in a negative slope? Jacob? It'll be positive, right? Because a negative divided by a negative is a positive. So in order to get a negative slope, only one of these will be negative. Doesn't matter which one, but only one of them is going to be negative. I say that because part of your homework, in addition to finishing what we have up here, part of your homework is to be making your own XY table with at least 4 ordered pairs. And I ask you for a slope of -2/7. If you make both your change in y and change in x negative, it's actually going to become positive 2/7. So one of these is going to have to be negative. If you make your your y change negative and your x change positive, that's the same thing as making your y change positive and your x change negative. Those two fractions have the same value. So it doesn't matter which one goes down and which one goes up, but make sure only one of them does. For the next one, where you have to make your own with a slope of 5/4, what are your options? What's going up? What's going down here? If you want a positive slope of 5/4, what's going to be going up? What's going to be going down? Aiden. Both be going up, or both be going down, because a negative divided by a negative is a positive. Okay? So either your change in y and change in x will both be increasing, or they'll both be decreasing, because negative divided by negative is a positive. Okay? Questions on any of this? It's a single page objective. Tomorrow sounds like a great day to play the number game. Let's all get it done, including these questions on the bottom. Sometimes folks tell me they don't realize they have to do these. Yes, they're on the page. Yes, they are questions. They need to be completed, but highlight those there. Okay? Questions, comments, concerns, complaints, comments, congratulations, and criticisms? All right, folks, that's iMath.